So this video covers the homework on WebAssign 5.1 Integrals 1, and we're going to do a couple questions here. I think we're going to do 1, 4, and 6. They're the most commonly missed. So on number 1, it says find the sum of the areas of the shaded rectangles of the graph. Round your answer to 2 decimal places. So notice here there's actually 3 rectangles, 1, 2, and 3 rectangles here. And we want to compute the area of each rectangle, and so the area is equal to of these rectangles. Well, the height here, if you plug in 1 into your function, you're going to get out 4 square root of 1. That's the height. If you plug in 2, this height is going to be 4 square root of 2, and if you plug in 3, this height is going to be 4 square root of 3. And so the area of this first rectangle, so number 1 rectangle, number 2 rectangle, number 3 rectangle, is going to be the length times the width, or if you want the length times the height. So the length here is just 1. Notice the length for each of these is just 1. And so it's going to be 1 times 4 root 1. So 4 times 4 root 1, which is just really 4, plus the area of the next rectangle, which is 1 times 4 root 2, plus the area of the third rectangle, which is 1 times 4 root 3. And so this is just going to be equal to 4 plus 4 root 2 plus 4 root 3. And I'll use my calculator to approximate this to 2 decimal places. So I have 4 plus 4 second square root of 2 in parentheses plus 4 second square root of 3 in parentheses, and I get out about 16.59, so approximately 16.59, and this would be then units squared. They don't tell me the units, but whatever the units are, they're just those squared, so 16.59. The next problem, number 4, it says use the midpoint rule with the given value of n to approximate the integral. So here n is going to be equal to 4, and so I'm going to have 4 rectangles, and I want to approximate this integral with those 4 rectangles. So first, let's figure out the graph. So on my calculator, I can graph this by hitting y equals and plugging in the original formula. So I'm going to clear all this stuff out. So I have second square root x raised to the 2 plus 3 in parentheses. And my window is going to go from 2 to 10. And then I'm going to zoom fit it. So zoom fit. It should give me a nice looking little graph here. So it goes from 2 to 10. And it looks kind of like this. And I want to make 4 rectangles here. So on here I want to make my 4 rectangles. And to do that, I have to divide 2 and 10 up into 4 pieces. So that's not too hard to do. I can do this 2, 4, 6, 8, and 10, and I can draw my rectangles on here. I'll draw them in blue. And I want to use the midpoint rule, so the midpoint between 2 and 4 is 3. So there's a height here when you plug in 3, which is given by the square root of 3 cubed plus 4. So the height's 3 cubed plus 4. And then right here at 5, I'm going to plug that in. I'm going to get a different height. So right here at 5, I get a different rectangle, and that's going to be 5 cubed plus 3. Right back here, this should be a 3, so let's change that. So 3 cubed plus 3. And then I'll have another rectangle right here. The midpoint is 7, and I'll have some height here, so I can draw the rectangle. And that height will be the square root of 7 cubed plus 3. And then the midpoint between 8 and 10 is 9, and that'll have some height here, which again I figure out by simply plugging into the function. So I have 9 cubed plus 3. And so finally, for my area A, it's going to equal, there are 4 rectangles, 1, 2, 3, 4 rectangles. And I'll find the area of the first one. So the area of the first one is this, what do I have? I have basically the length times the height here. So I'm going to have 1 times the square root of 3 cubed plus 3 plus 1 times the area of the second rectangle is the 1 times this height right here. So the square root of 5 cubed plus 3 plus 1 times the square root and this third rectangle, so 7 cubed plus 3, that's the area of the third rectangle, plus 1 more, so plus 1 times the square root, sorry, of 9 cubed plus 3. And I'll use my calculator to approximate this. So take out your calculator. Let's move it over. Let's clear the screen. And I simply plug in what I have over here. You don't need to plug in the 1, so I just have the second square root of 3 raised to the 3 plus 3 in parentheses plus second square root 5 raised to the 3 plus 3 in parentheses plus second square root 7 raised to the 3 plus 3 in parentheses, and then finally plus second square root 9 raised to the 3 plus 3 in parentheses. And so I get out, if you round to 2 decimal places, oh, it says round to 4 decimal places right here, so 4 decimal places, I'm going to get out 62.4475, so 62.4475. Oh, and I'm off a bit. Why am I off a bit? Because the length of this interval is not 1. I'm actually off by a factor of 2. The length is 2, so these should actually be 2's. So correct that. That should be a 2. That should be a 2 because the length of my rectangle is 2. So maybe you caught that. And so I'm going to multiply this by 2. So it's 2 times that number. So on my calculator, I just multiply this by 2. And I get 124.90. So this one is actually approximately 124. In 4 decimal places, so 0.8950. So that's the answer. All right, so understand the idea. You're simply adding up areas of rectangles. And if you draw the picture and are careful, you should not make too many mistakes. But you have to draw the picture to do this. The last example we're going to do from your homework is number 6. And this one's actually pretty simple if you put it in correctly. So you want to use your calculator to evaluate this definite integral. So the last 4 problems were just like this. And the issue with this one, so you take out your calculator, is how do you put it in to your calculator? And so what I want to do is I want to graph this integrand here. And so what I'm going to do is put in the cube root. Remember, this is the same thing as the integral from 1 to 27 of x to the 1/3. It's the same thing as the cube root dx. And so on my calculator, I can put this in by doing x raised to left parenthesis 1 divided by 3 in parenthesis, then making my window go from 1 to 27 and zoom fit it. And so I get a graph that goes up and kind of levels out just a bit, but it keeps going up. So it goes sort of like this. I'm going from 1 to 27. And remember, when I say integral, you say area. So this is really the area underneath the curve there, and I can figure that out by hitting second trace to pull up my calculate menu. And then once you know where to go, you know what to do. You go down here to this integral of f of x dx, and it's asking you for the lower limit. Of course, the lower limit is 1, so you hit 1 and enter. Then it says upper limit. Your upper limit right here is 27, and you hit enter. And it's going to shade in this region and spit out the number, hopefully 60. And so that's equal to 60. So you put 60 in that box right there.